So from Friday, what is the rule, or what's the one thing that we asked you to remember about matrices from Friday?
That you have to have the same rows and columns. I think that's what they call it. In order to add and subtract the matrices.
Okay, but just in general, can we just shorten that up to just rows by columns? Everything with matrices involves rows by columns. Okay? Size, if you will, if you want to remember it even easier, size matters. Okay? Everything with matrices is rows by columns. The size of a matrix, the address of a particular element, if we can add and subtract them, if we can multiply them, that's what we're going to learn today. If we can find their determinants, if we can find their inverses, all that stuff is based off of the size of the matrix, okay? Which is rows by columns. Size does matter. Your note sheet today, by the way, is organized by slides, so you know exactly where we are and what I have to get through all the way through. Okay, so this was slide number 1. Now we're going to slide number 2. Okay? Today we're going to focus in on matrix multiplication. Matrix multiplication, we've already mastered scalar multiplication. That is different. Scalar multiplication deals with taking a single matrix and multiplying it by a number. Basically increasing or decreasing the individual elements of that matrix by a number. Okay? Distributive property is how I described that on Friday. Okay? Today, we are going to multiply matrices. And when we multiply matrices, the very first thing that we have to do is we have to determine if it can work and if it cannot work. Okay? I can multiply any two numbers together. Okay? And the order that I multiply them in doesn't matter. 2 times 3 is 6. 3 times 2 is 6. Okay? 15 times 4 is 60. 4 times 15 is 60. I can multiply those all together. But in matrices, that is not the case. Okay? In matrices, we have to look at, actually I can get rid of this whole thing. We have to look at their dimensions first. Okay? So you have to take, when you're multiplying two matrices, you're going to have one on the left and one on the right. So you have to line up the dimensions of the left one on the left and with the dimensions of the right one on the right. So for instance, in this particular case, I am multiplying a 3 by 2 matrix by a 2 by 1 matrix. And I can do that because these middle two dimensions are equal. If those middle two dimensions are not equal, you cannot multiply the matrices together. Okay? So I can multiply them if I multiply them in this order. If I switch the order, if I went 2 by 1 times a 3 by 2 matrix, now these middle two numbers are not the same, and therefore I cannot multiply those two matrices together. Order matters in matrices. Okay? I'll say that again. Order matters when you're multiplying matrices. Okay? The cool thing about setting up the dimensions like that is then these outer two numbers are the resultant dimensions. So this is going to produce a 3 by 1 matrix after I multiply it together. So what are the dimensions of the answer matrix for the problem below? So if I had a 2 by 3 matrix and a 3 by 5 matrix, I could multiply them together, correct? Yes or no? Yeah, I could, because these two numbers are the same. And my result then is going to be a 2 by 5 matrix. And on the next slide, we'll learn how to fill in those 10 elements. Okay. In B here, can I multiply those two matrices together? No, because these two here in the middle are not the same. So this is not possible. Okay. However, if I switched the order, if I went a 3 by 2 matrix times a 2 by 2 matrix, that now becomes possible, but it's a different problem than the one that we originally had. So I can't just flip-flop them and say, yes, this is their product, because order matters. Okay? It's a different problem, but now this is legal, and then that gives me a 3 by 2. Okay? Let's get into it. Okay? So that's the first thing that we got to do when we multiply matrices. We've got to find the dimensions of our result, because that's going to tell us if we actually get a result or if we're just done because we can't go any further. Okay? So on this left matrix, what is the dimensions of it, of just the left one? 3 by 2. 3 rows, 2 columns. Rows by columns. Everything is rows by columns. Right matrix. What are the dimensions of the right matrix? 2 by 1. Can I multiply those two matrices together? Yeah, I can. Okay, we got the green light because we've got 2's in the middle. Okay? And my result is going to be what size? It's going to be a 3 by 1. So now this is how I do this. I draw myself a rather large 3 by 1 matrix. And now I've got to fill in those elements. Well, again, matrices, everything that involves matrices is rows by columns. So I'm going to take the rows of the first one, and I'm going to multiply that by the columns of the second one. So I'm going to take the first row, first column, and I'm going to multiply those numbers together. 5 times negative 2 plus, 3 times 3. Rows by columns. Then, because that's row 1, column 1, I take the first row times the first column. This is row 2, column 1, so I'm going to take the second row times the first column. Negative 1 times negative 2 plus 2. Oops. Two times 3. Row 3, column 1. So I'm going to take the third row times the first column. Okay. 5 times negative 2 is negative 10. 3 times 3 is 9. Negative 1 times negative 2 is 2. 2 times 3 is 6. Negative 4 times negative 2 is 8. 3 times 0 is 0. Negative 10 plus 9 is negative 1. 2 plus 6 is 8. 8 plus 0 is 8. So my resultant matrix is a 3 by 1 matrix, which we knew that from the start. Negative 1, 8, 8. Okay. Can I multiply those matrices together? Dimension check tells me I've got a 2 by 2 and a 2 by 2. Green light. And my result is going to be a 2 by 2. So again, I would make myself a 2 by 2 matrix that I can now fill in. Row 1, column 1 says row 1, column 1. 4 times 5 plus negative 3 times negative 1. Row 1, column 2. Row 1, column 2. 4 times 0 plus negative 3 times 3. Row 2, column 1. Row 2, column 1. 2 times 5 plus 1 times negative 1. Row 2, column 2. Row 2, column 2. 2 times 0 plus 1 times 3. Uh, 20 plus 3, 0 minus 9, 10 minus 1, 0 plus 3, 23, negative 9, 9, and 3. Okay. Try that one. So, can I do this? Yes? Okay, because this is a 3 by 1, and this is a 1 by 2. So my result is going to be a 3 by 2. Five times 2 here. 5 times negative 4 here. 6 times 2 here. 6 times negative 4 there. Negative 2 times 2 here. And negative 2 times negative 4 there. Gives me 10, negative 20, 12, negative 24, negative 4, and 8. Yes? Love it. Doable? Not doable. Why not, AP? And those middle two numbers don't match up? Those two aren't the same, so it's not possible. Solving for x and y in this one. Well, let's see. So, can I multiply those two matrices together, the left side? If I were just to look at that, can I multiply those together? Yeah? 3 by 3 and a 3 by 1 ends up being a 3 by 1. Okay? So that works out. Okay? So if I take my first row times my first column, what does that have to equal? First row times the first column has to equal what? Negative 2. It's got to equal this value right there. Okay? So negative 2 times 3 plus 1 times x plus 2 times 1 has to equal negative 2. Well, negative 2 times 3 is negative 6. 1 times x is x. 2 times 1 is 2. So negative 6 plus x plus 2 has to equal negative 2. Or x minus 4 has to equal negative 2. Or x has to be positive 2. If x is positive 2, then the second row times the first column should be 17. So that would be 3 times 3 plus 2 times x plus 4 times 1, and that's got to be 17. Well, we already said x was 2, so this is going to be 9 plus, if x is 2, that one's 4, plus 4 has to be 17, and 17 is equal to 17. third row times the first column has to be that value right there. So that would be 0 times 3 plus -2 times x plus 4 times 1, and that has to be y. Well, we already know that x is 2, so that's going to be 0 minus 4 plus 4 equals y. So 0 is y. So if x is 2, y is then 0. Okay. Determinants now. Okay. So a determinant takes a matrix and it trims the fat, boils it down, or whatever you want to call it, down to one value. And we need that value going forward. Side note, tonight you have some homework this evening that you have to watch. I think it's either 3 or 4 videos totaling less than a half an hour for class tomorrow. Okay? So if you watch them tonight, then you'll get work time in class tomorrow. If you watch them in class tomorrow, then you don't get work time in class tomorrow because you're watching videos on what we're talking about, and you lose out on getting questions answered about the next topic. Okay? So it's a flip night tonight. Okay? But we need determinants to go to the next step. Okay? The next step is solving systems of equations using matrices. Okay? And so we need determinants to do that. Okay? The kicker with a determinant is the matrix must be square in order to have a determinant. By square, the rows have to equal the columns. If it's a square matrix, we can find the value of the determinant, and we can use that to solve systems of equations. Okay? Kicker, gotta be square. So, 2 by 2, the easiest way to do a 2 by 2 matrix, or 2 by 2 determinant, is by hand. Okay? It's just simplest by hand. Okay? So what you're going to do is you're actually going to utilize something called the crisscross method, or downs by ups. So whenever I do this, I always like to go Side note, this is the band Crisscross. Their song Jump. They were famous back in the, I want to say, 90s because they wore all their clothes backwards. That was their thing. So, I wait for my favorite part of the song. Right there. It's wiggity, 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 whack. Alright? So, what you're going to do is you're going to take your crisses and you're going to subtract off your crosses. So this is a criss. Okay? So the determinant is going to be A times D. And then you're going to subtract off your crosses minus C times B. And crisscross will make you want to jump, because you just found the value of the determinant. Criss minus cross. Oops, too far. So if I want to find the value of this determinant, side note, actually let me go back a little bit here. Side note, a matrix has the symbol with brackets. Okay? So a matrix has a symbol with brackets. A determinant, which is in short is DET. Okay, DET is the symbol for determinant. The determinant has straight sides. Matrix, brackets, determinant, straight sides. Okay? So now, this is asking us to find the determinant of this because it's got straight sides. So I take my crisses, 6 times negative 4, and I subtract off my crosses. 1 times negative 2. 6 times negative 4 is negative 24. 1 times negative 2 is negative 2. So the determinant here of this matrix, we'll call it matrix A, is negative 22. Determinants can be negative, they can be positive, they can be 1, they can be 0. Okay? So they could be all of those, any kind of number there. Find me the value of the determinant of this 2 by 2. I get 15 for the value of that determinant. Yes? Okay. Now, let's kick it up a notch. Let's find the value of the determinant. You got two choices. We can do it by hand, or we can do it on a calculator. Okay? So let's show you by hand first. There's two different methods to finding the value of a 3 by 3 determinant by hand. One is called using minor determinants, and that is you take, so I would take this number here and I would cross out its row and its column, and I would say that this would be 4 times the determinant of what's left over. Then I would go to the next number in that row. And I would cross out that row and that column, and I would go 1, -2, 2, and 3. Then I would go to the next 1. Cross out the column, cross out the row. 1, 1, 2, and 5. But to go along with that, I've got to remember that the pattern is plus, minus, plus, minus, plus, minus, plus, minus, plus, depending upon which row I take. So I would have a plus sign there, a minus sign there, and a plus sign there. Okay? 3 minus negative 10 is 13, times 4 is 52. 3 minus 4, or minus negative 4 is 7, times negative 2 is negative 14, so it's minus negative 14. This one I'm not even going to calculate, because it's going to be 0. So the value of this determinant is 66. That's one way of doing it by hand. Okay? That's the long way, the most complicated way. I started with it because you'll probably never use it after that. The last time that I did that, before 2 hours ago when I did it in my class, actually before an hour and a half ago in my last class, was 25 years ago. That's the last time I did it that way. Okay? All right? There's another way. Another way by hand is to, and this is the way that you would probably do it if you had to do it by hand, is to copy down the first 2 columns. Now what you've set up is you've set up 3 Chris's, so this would be 4 times 1 times 3 plus negative 2 times negative 2 times 2 plus 0 times 1 times 5 minus your 3 crosses. So that's what? 12 plus 8 plus 0 minus 0. 20, 40 minus negative 40 minus negative 6. 20 plus 8 is, or excuse me, 12 plus 8 is 20. Minus 0 plus 0 is still 20. Minus negative 40 is 60. Minus negative 6 is 66. A little easier. You don't have to use any patterns, plus, minus, plus, alternating positive signs on that one. Okay? Last way is utilizing a calculator. on the Inspire calculators, I can type in DET, and that sets up my determinant. If I open up a set of parentheses, then I can put in a matrix. The matrix shortcut key is in the shortcut key, and it's this blue one right here. That allows me to set whatever size I need of the matrix. In this case, I want a 3 by 3 matrix, and I would go then type in -2 and 0, 1, 1, and -2, 2, 5, 2, 5, and 3. And then just by hitting enter, bam, there it is. Okay. So again, more than one way to do that. We showed you all of the methods. The reason we showed you all of the methods is because we are probably going to want you to show them using multiple methods in the future. Okay? Okay? Now, what I have for you up here in the last 5 minutes, I'll pass these out. I have for you some selected homework problems to go along with matrices. Worksheet number 1 was from last week, Friday. Okay. Worksheet number 2, which is actually the next page, is from today. You can do both of those now. Worksheet number 3, just to save paper, I put it on the back side of worksheet number 1 because those were single-sided ones. We'll get to that